Today we're going to talk about the properties of gases, which is chapter 11. And in order to talk about the properties of gases, we're going to use a theory called kinetic molecular theory. And kinetic molecular theory is basically just a model that describes how gases behave. So there's 5 different postulates in this theory, and I'll go through each of them. The first is pretty simple. A gas consists of small particles, which are either atoms or molecules, that move randomly with high velocities. So all that says is that gases are made up of teeny little particles and they're moving around a lot in random directions and they're moving fast. All right, the second one is the attractive forces between the particles of a gas are usually very small. And what this means is all the attractive forces we learned about in the last chapter are basically non-existent in gases because the molecules are farther apart. The third one is that the actual volume occupied by a gas molecule is extremely small compared to the volume that the gas occupies. And so what this means is that if we were to draw the gas molecule, all right, and another gas molecule over here, this is actually much, much, much closer together than they would actually be. So what it's saying is the volume of this particle is so small compared to the distance between particles that we can basically ignore the volume. All right. The fourth one is that gas particles are in constant motion, moving rapidly in straight paths. So while they are moving randomly, they move in a straight path until they hit something that causes them to change directions. So that straight path could be in any direction, but it will be a straight line. All right, and then the fifth one is the average kinetic energy of a gas molecule is proportional to the temperature in Kelvin. So for the most part this semester or this year we've only used temperatures in Celsius, but for the gas chapter all of our temperatures have to be in Kelvin. All right, and we'll go over in more detail how that affects our calculations and how to get that temperature. But basically what this means is that proportional just means that as one goes up, the other one goes up, or as one goes down, the other goes down. So as the temperature increases, the energy of our particles is going to go up, and as the temperature decreases, the energy of the particles is going to go down. All right, so there are different properties of gases that we're going to be using throughout this chapter, and so I just want to introduce each of them now. So pressure is a result of the particles or the gas molecules or atoms hitting the walls of the container. And so when they hit the walls, that exerts a pressure on the container, and that's something we can measure. Atmospheric pressure is defined as the gas particles from the air in our atmosphere, which is mostly oxygen and nitrogen. They exert a pressure on us all the time because there are molecules moving around us and hitting us, which exerts a pressure, and that is what we call atmospheric pressure. And pressure is measured in, typically what we're going to use in this class is atmospheres, but it can also be measured in millimeters of mercury and sometimes also torr or pascals. But usually in this class we'll use either atmospheres or millimeters of mercury. Okay, so now let's talk about volume. So volume, we've talked about before. It's usually measured in liters. And volume is just, for a gas, the size of the container, because the gas will take up as much volume as it's given and will expand to the volume that you give it. All right, temperature. As I said, for gases, we want to measure the temperature in Kelvin. So just as a reminder, the temperature of 0 degrees Kelvin is absolute zero, and that would be where there is no kinetic energy, no motion, no thermal motion at all. And so 0 degrees Kelvin is as low as you can get in terms of temperature, and that equals 273 degrees Celsius. So in order to get from Celsius to Kelvin, if a problem gives you Celsius, you need to add 273.15 degrees in order to get to the Kelvin temperature. All right, and then the last one is the amount of gas. And so our amount of gas can either be given in moles or it can be given in grams. And so we know that what we would actually measure in the lab is grams, but we know how to get from grams to moles using the molar mass from the periodic table. And so finally, I just want to go into a little more detail about what pressure is. So pressure, in terms of physics, is defined as the force per unit area. So F over A. All right, and now that might not mean a lot to you, but if you think about a circumstance in everyday life, if you have two people that are the same weight, in this picture they aren't the same weight. The woman is actually probably lower weight, but you can see that her area on her shoe down here is very small, and so she doesn't have to exert a lot of force to get her heel to sink into the ground when it's a little bit wet or soft. Whereas this gentleman over here is exerting more force because he has a larger weight, but his area is much bigger, and so the pressure he's exerting is less, and so he doesn't sink into the ground. Okay, and so it's going to be similar with gases. So the more force that you exert on a given container, the higher the pressure will be. But as the area that force is being exerted on goes down, then your pressure is going to go up. And we'll talk about this in more detail in class, and we're going to do some simulations to look at how gases behave. All right, and so I just want to give you an idea. We talked a little bit about, or I mentioned, atmospheric pressure. So at sea level, atmospheric pressure is defined as 1 atmosphere, which is equal to 760 millimeters of mercury. And then as the altitude changes, the amount of pressure that the molecules in the air exert on us changes. So as you go up, so if we go up to Mount Everest, the pressure that's exerted on us is much less because there aren't as many molecules pushing down from above because we're higher. All right, and then again, if you were to go to the Dead Sea, which is below sea level, then the pressure is going to be higher than it would be at sea level. All right, so that wraps up our introduction to discussion of gas properties. And then we are going to spend some time this chapter looking at how these properties are related to each other and how if we change one, that might affect the other properties.